In this video, we'll discuss running the decision tree regression function using UnifyML SQL. We'll execute the UnifyML decision tree regression algorithm through a UnifyML query. Here, we demonstrate how to run UnifyML decision tree regression functions using UnifyML SQL. Now, let's take a look at a simple UnifyML decision tree regression function. Before running the regression function, we'll first examine the dataset used for the decision tree regression. For this example, I'm using hospital length of stay as my dataset. This query is limited to focus on the relevant data. These are the columns in the hospital length of stay table. Unique ID of the patient, gender of the patient, presence of conditions such as dialysis, asthma, iron deficiency, pneumonia, substance dependency, psychological disorders, and depression. These input columns or feature columns serve as the basis for predicting a patient's length of stay. Using these features, we apply the UnifyML decision tree regression function to estimate the number of days a patient will remain in the hospital. Decision tree regression function parameters. Input table, define the required input table. Feature columns, specify the input column names. Target column to be predicted. Max bins, maximum number of bins. Max depth, maximum depth of the tree. Min info gain, minimum information gain. Seed, random seed parameter. Training sample size, proportion of data used for training. The dataset is split into training and test sets. Specify the training data value with the remaining portion serving as the test data. The model is saved for further predictions using the UnifyML decision tree regression function. Additional parameters and model tuning. You can explore more parameters through the UnifyML documentation, including input columns, target column, input table, and input data types. To modify data types, use the input data types parameter. Hyperparameter tuning for model optimization includes two methods: train validation and cross-validation. Key hyperparameters include max bins, maximum number of bins, max depth, maximum tree depth, min info gain, minimum information gain, seed params, randomization settings. Parallelism enables parallel processing. Number of folds for splitting training and test sets. Number partitions specifies partitioning strategy. Apply PCA model. Set Boolean to true if PCA should be applied. Data pre-processing and scaling. Data cleaning includes four methods: remove rows, remove duplicates, remove outliers, and fill values to replace null values or update specific data points. For data scaling, the available methods are min-max scaler, define min/max values. Standard scaler, normalizer, and binarizer. If the data is already cached, specify the input cache ID instead of the input table. Other parameters include bytes per chunk, which defines processing size. Executing this query runs the UnifyML decision tree regression function on the backend. The output includes MSE mean squared error, MAE mean absolute error, RMSE root mean squared error, our superscript 2 value, prediction accuracy, and output model name, save model. Running predictions with UnifyML decision tree regression. To make predictions, specify the predict input table name. Load the saved input model. Additional parameters are available in the UnifyML documentation. Prediction-specific parameters. Data cleaning and scaling, same methods as above. Input cache ID. If previously saved, no need to specify an input table. Save to DB. Save predicted results to a database. Overwrite output table. Set Boolean to true to overwrite existing data. Save to CSV. Save predicted output as a CSV file. Run the query, and UnifyML will process it on the backend. The output consists of feature columns as input and the predicted column, length of stay, representing the estimated hospital stay for each patient based on input features. By following this method, you can apply the UnifyML decision tree regression function to any regression dataset. Thank you for watching this video.